Noise. All right. My name is Jason Lee. For those of you who don't know me, which is, I think, going to be most of you, I don't know most of the faces here, which is fantastic. So anyway, we're going to talk about building microservices with Micronaut. Just a quick look at the agenda, and who I am in case you care, what it is, a quick overview of the features, then we'll walk through building an application. I've got a lot of the code, just a heads up, actually in the slides, but I'm going to try not to spend too much time there. Some people like leaving presentations, have a slide deck they can look at, kind of pull the relevant bits out. So that's what they're there for, but I do hope to spend as much time as possible in the slides. So who am I? I'm a senior principal software engineer for Oracle. I was elected to qualify NetSuite. I was at DevNexus last week and meeting some people, and they would find out who I worked for, and they always make a funny face. And certain parts of the organization does have a bad reputation, but other parts are pretty awesome. Any large organization kind of gets that way. But I'm on the NetSuite side. We were acquired by Oracle 2.5 years ago or so. We make it's software as a service, ERP, financial stuff, which is probably as boring as it sounds. ERP is not really exciting, but it does make a good deal of money for the company, so that's pretty cool. But I work on our e-commerce side, where we build a system called Suite Commerce that allows people to build e-commerce sites for the website. Far more detail than you care to know, but it's a WYSIWYG tool. There's some other stuff to it, but I also wrote Java 9 programming blueprints. We're about to release Java 12, so it's a little out of date, but still some good stuff there, I hope. And I like to throw it in there because I spent a good long year working on that. Excuse me. All right, so what is Micronaut? It is fairly new. It's not quite as new as I thought. I was first exposed to it really just a couple months ago. I was working on kind of a side project, building a little microservice-y thing and a mobile front end. And 1.0 was released recently, and of course that usually makes a little more press. So it's actually been around since I think May of last year, maybe the year before. It's been around for a little bit, hit 1.0 recently. But it is an opinionated JVM framework for building microservices and serverless functions. The opinionated there is important. We'll look at, kind of list some alternatives that are in the same space later, but there are a lot of frameworks out there that said, here, go build your framework, or go build an application, and if you want to throw in persistence of some sort, or integration of something else, then a lot of times you have to kind of do the work to make those integrations, and that can be really painful. Micronaut's goal is to allow you to build applications of various types as quickly as possible. So it's opinionated in that, hey, you're probably going to use JPA, or you might want to use Kafka. We've got integrations for that. It is, of course, open source, so you can write your own, but it has some ideas of how a microservice maybe perhaps should be built or could be built, and kind of does as much of that for you as you can. So that's always good for me. I like hacking on some of those integrations, but sometimes you just want to get stuff done, and Micronaut's kind of optimized for that. And speaking of optimizations, one of the goals is fast startup times. You've got people, I think Tim Bray is suggesting don't use Java for microservices, for lambdas and that kind of thing, because the startup time is just too expensive. So one of the goals of Micronaut is to reduce those startup times to as small as possible. And I actually have, if we have time, I've got an example of a command line utility written in Micronaut, compiled to a native Linux executable using the Gradle VM that starts up in 0.15 of a second, just super fast. If you go to the official, you like hear one of the Micronaut people talk, they have a web service that it also compiles down to native, and it's up in less than a quarter of a second, actually running, taking requests. So it's very, very cool. Low runtime memory usage. If you're in a Lambda environment or somewhere where you're paying by resource utilization, they want to keep that as small as possible. So a lot of the frameworks are out there. People tend to point to Spring Boot. I can't say whether or not those are accurate accusations or not, but tend to use a lot of memory. And then Java is just known in general as being very resource intensive. So they wanted to make something that was very, very small memory usage. One of the ways they do that is a minimal use of reflection. I won't spend a lot of time on it here, but at compile time, they have an annotation processor for Java and Kotlin that actually analyzes all of your source code, looks at the annotations, looks at your injection points, and builds a map of sorts for how to do the injection. Anything that needs a round advice, AOP, it will generate classes dynamically at compile time and save that bytecode. So when you run your application, you don't do, it does hardly any reflection at all. The core of the framework is, I believe, they said 100% reflection free. All of your dependency injections all computed at compile time. You do run into some reflection later if you're using Hibernate or some tools like that. They can't control that, but in terms of the framework, it's all computed at compile time, which is pretty cool. They wanted to minimize dependencies. Everybody says, well, why make a new framework when you've got Spring Boot out there? But if you've worked in the Spring environment, it seems it has grown quite a bit. It's not quite as bad as the Node world where importing left pad, but you bring in one Spring dependency and it just spiders. You've got a lot of dependencies, and they tried to minimize that. And of course, the more features you add, if you want Kafka support or console or whatever, it's going to pull in those libraries, and it's kind of hard to avoid. But they've minimized that, and they've actually rewritten some classes, which escapes me, to avoid some of the reflection issues and some of those dependencies. So the on-disk space is lower. And simple and fast testing, that's always one of the hardest parts for me in a Java environment, is when you're writing some new server-based stuff. How do I test this? I'm a pretty big fan of Archelion, at least the idea product from JBoss that allows for in-container testing, but I don't use it often enough. So every time I go to reuse it, I have to dig through the documents, try to find an old project, copy and paste, and see what's changed and tweak. As we'll see later, the testing in Micronaut, I fail to see how it could be any easier. It's pretty mind-numbing. So overview of features, just to give you an idea. We won't look at all of these today, but at least talk about them. It's built on reactive streams. You'll see, especially like in the HTTP client and even in the controllers. You can do it in a more traditional sense, or you can actually use the reactive APIs. It's compliant with any framework that implements the reactive stream standard, and that include RxJava, and there's what Project Reactor, I think it was. There are a couple others. So anything that implements that standard, it's compatible with. It includes reactive drivers for some popular databases, Mongo and PostgreSQL. Cloud native features, they didn't want to just replace Java application frameworks or application servers. The world's kind of moving toward cloud native stuff, whether it's Lambda or something a little larger. But they built all these features in, resilience features, service discovery, tracing, config sharing, that sort of thing. Everything you might expect if you can go deploy to an AWS or an Azure environment, that kind of thing. Those types of libraries you see in a microservice environment typically, they do have support for out of the box. And I won't get into it necessarily here, but at the DevNexus conference last week, they had an example where they would annotate a client. They would inject a Typesafe client, and they'd give it an ID, and the ID would look at the config and knows it needs to go to console, so it knows where to talk to console, and it would get the URL for the service. So we're injecting a client that connects to an external service based on a configured ID, looks up in console, and console load balance for them is all based on config, changeable at runtime. It was really pretty slick, all with an annotation. Also, message-driven microservices. Not every microservice is a REST API, for example. If you've got a Kafka listener, for example, you just want to listen on something and maybe publish something else, it's got support for that. Very, very easy, some annotation, but a YAML, we'll see some YAML here a little bit for configuration, and you can stand up a Kafka listener with minimum of effort. And like I said, serverless functions that got support for some AWS Lambda development and some of those libraries built in. Open API support. If you like Swagger, some people do, some people don't. At compile time, it will create a YAML document of your REST interface that you can then publish or do whatever you want to with, and that kind of comes for free. And Gradle VM support, I mentioned that. If you don't know what Gradle VM support, it's an experimental just-in-time compiler from Oracle Labs. It's approaching 1.0 that just released RC13, so they're taking their time. But it replaces the hotspot JIT compiler. It's all written in Java, very, very fast. And one of the features of Gradle VM is that it supports native compilation. So through an extra step, you can actually build your Java project and run this native image tool, and it will build an executable that's native for your platform. So you can actually ship a Windows executable. Well, you can't ship Windows right now. They're still working on trying to figure out how to support that, but Mac and Linux are supported in the release candidate. So if you've got a, I don't know, microservice or a desktop app perhaps, in theory, you can compile down to native and ship that. So you can get an executable that's like 40 meg, and there's no external dependencies. You're not spinning up a Java virtual machine. Very, very cool. And that's what I use to get that millisecond startup time. All right, so that's what it is kind of in a nutshell. So let's get to building an application. Micronaut, I'm not going to go over how to install it. You guys can go read the docs and figure out how to extract an archive. It's pretty simple. It is an SDK man, so if you use that, you can install it that way. So maybe homebrew, I don't know. I'm on Windows. So for building an application, it does provide a command line tool. So you can just open up a shell, and you can create, as you can see, an application, a CLI. I have no idea what a federation of services is. I'm not going to lie to you. Serverless function. A profile is probably a little more technical. It kind of groups features. The default profile is the services profile, I believe, for building an endpoint or a REST API type thing, and that's what we'll look at. There are several profiles there, as you can see: CLI, AWS, gRPC, Kafka. All right, and the service profile is loaded with features. If you ask it to describe the profile, I know you can't read all of that, and you're not really meant to. It just kind of show these are all the features. That's 2 screenfuls I had to cut and paste, but you can see we've got options for AWS API Gateway, Cassandra, Discovery, Hibernate, some connection pooling stuff, a couple of testing libraries, Netflix APIs, monitoring. It's a lot of stuff built in, and when you create your application, you can tell it to use those features, and it will go in and kind of stub out a lot of that stuff for you. Add the dependencies, create your basic configuration, and kind of get you started. You can always go back and add those, of course, and the guides are really good about, if you decide, well, maybe I do want to use some discovery. So it'll tell you, add this dependency, either Gradle or Maven, and here's your config. So you can add it. This just saves you a little time up front. It is worth pointing out, you can see it supports Kotlin there, it supports Groovy and Java. I'm going to do this in Kotlin because I can, but it does support those 3 languages out of the box. If you like, if you like your language, you can use your language. If you like Java, you can use that. It comes from the creator of Grails, so they're very big into Groovy, so they port that out of the box, as well as Java. To create the application, this is basically what I did here. I'm going to tell it to use Kotlin. I want to use Hibernate and JPA. I want to secure this with the Java JSON Web Token, not Java Web Toolkit. And I will use JUnit to test. The package name there is a little weird. I actually saw the OCI guys do this. The package is com.steeplesoft.micronaut.jug demo, and it's going to take that last section and create, that'll be the director name, and use the rest of it as the package. So to keep jug demo in the package name, I had to repeat that. Seems kind of weird. I don't know if it's a bug or a feature, or maybe I'm just using the tool wrong, but that's what that's all about, and it'll spit out that. Yep, so I put some build updates in there, because when I started using this, I was using an old version of Micronaut, and they've kind of updated it. So some of this isn't necessarily real current, but I'll go and put it in there. I like using the latest version of things, because it makes things break a little more obscurely sometimes. But It's using an older version of Kotlin, so I upgraded that. I just want to call these out in case that's important to you. And it seemed early on that the testing stuff was a little weird. Now, I do show Gradle there. I'm actually using Maven in the example here, but Gradle fits on the screen better than all of that in Maven XML. All right, so when we run that, if I can find the right window. There we go. I'm not mirroring my screen, so this is going to be a little weird for me. And that is, I hope that's easy enough to read. So this is what the, you can see some old Gradle stuff right there. The project is going to build, not all of this comes out of the box, but it's going to create the basic structure. It creates this application class, and that's our entry point. You don't ever have to do anything with that, but that's how we run it. Expand all, nope, you're not going to help me out, are you? All right, so that's the entry point. It just basically runs the Micronaut class and tells it which class to, or which package to look at. And we can take a quick look at the application YAML. There's a lot of extra stuff in here because I've added stuff to the config, but you can see, if you're familiar with YAML, there's nothing real new and exciting there. Yep, all right. So anyway, that's kind of how how the application is going to start. I mentioned the configuration is all externalized. You know, the one thing you don't want to have to do is rebuild your application every time you deploy it or move it somewhere else. So it does support externalized configuration, as any good microservice should. It supports a number of formats: Java properties, YAML, JSON, Groovy. So whatever floats your boat. It does support loading properties in a kind of a layered approach. So you can have some default properties. We'll actually see where I've got some default production properties, and I've got some properties for test, so that when I run my test, I can point to a different database, for example. Or if if you're deploying this to different data centers, you need to change some things. You can override that using some of these properties. The higher it is on the list, the higher the priority. So it'll start there at the top and just walk down until it finds something. Or maybe it starts at the bottom and reads up, I don't know. But the net effect is if you specify something on the command line, it'll override whatever might be in a config file. And again, the file extensions on those can be .properties, .json, .yml, and .groovy. All right, so we're going to create a REST service here. It's not a very exciting one. It's books and authors, and actually I got as far as, I think, authors. But a controller is the entry point. It's probably a term that's familiar to a lot of people. In the JAX-RS sense, it's an endpoint. So we can create a controller a couple different ways. It has a CLI. You can tell it create controller and give it a name. It'll put it in the default package. Also notice that the package there doesn't match what I had earlier because I got lazy on my slides. But it'll put in that default package. So and if that's wrong, then you just move it. There's no config file, so it's not something you have to change in 8 places, whatever. And you can also notice that you can create it manually if you want to. File a new Kotlin class. It's very easy. We'll look at the source. But you notice that the CLI currently creates a Java test class. That's not true anymore. I found out this morning. It's the latest version. If you're writing a Kotlin application, does create a Kotlin test, which is kind of nice, as you would expect it to do. So just a quick look at what the controller might look like. It's a plain old Kotlin object, POCO. Has anyone introduced that term yet? If not, I'm going to go on record. I'm probably late to the game, but I had to give it a shot. So it's pretty simple. You can see I included the imports there for people that like that, but you just annotate just any old class with the controller annotation. You give it the path. So if you have multiple controllers, obviously you want those listening on different URLs, and then you start specifying your methods. Here we have, this is the default controller generated. So when you say create controller, you're going to get this spit out there. Not very exciting, but you at least get a sense of what it looks like. So we've got one function get that's going to return an OK. Not super exciting. So we're going to try and test it, and I'm going to have to detour real quick and see if I can stop mirroring, because I cannot look over my shoulder and type up there. And so we want to duplicate. Yes, all right. So we're going to test it, and we're going to switch to apparently I can't type this way either. So we're going to go and execute that, and hopefully, of course, it's not. Class not, okay. The exec command does not. Point. Is that better? You want it bigger? Bigger. Wow. Too big? Well, one of my complaints at the conference last week is some guy had a shelf, like it was way down at the bottom, and you can't see it through people's heads. So I certainly want to make sure you can see that, although now it's we're still building. By default, the Maven build does install the shade plugin, so when you build the package, it finished with an error, but I can't tell what that error is. Address is already in use. I was really prepared. That's what you get for running through it earlier without cleaning up. And since my apologies. See if I can. I don't want to package it again. I don't want to wait through that. But it does build a fat jar, so you can just execute the jar, ship that java-jar, and everything you need is built in there. Well, that didn't help pull it either, does it? Well, it didn't error out, so I'm going to assume it's working. We'll just try a browser here. '8080. We'll go to author. And we should get a nice error. See that 401 there? All right. Which is not what you're expecting to see, but I put that in intentionally because it took me forever to figure this out. The problem is I asked it to use JWT to secure it with JWTs, which, by the way, is pronounced jot, so if that comes out, that's what I'm talking about. The W apparently makes an ah sound in English. I guess there are worse ways to try to say that, but she turned me into a jute. So until you're ready to secure it and that kind of thing, you come into your application YAML, just set enable to false, and I'm going to guess. I've had, and like I said, I'm fairly new to this, so I don't want you to think I'm standing up here as an expert, but I've had kind of an odd issue. Yep. With processes hanging around when you try to kill it. I'm not sure exactly how to fix that just yet. But if you're running on Windows, you might run into that as well. And I don't quite understand why it's not scrolling like that, but I think that's what I get for using Windows. Oh, there we go. It just needed to clear its mind. Server started up in 4.7 seconds. Not super exciting, but there are ways to fix that. And if we come back over here, we should now get, 401. Oh. Same mistake I made earlier. Maven exec does not package. So since I don't have an override on the, yep, of course I killed the wrong process. I'm really pushing my luck doing stuff kind of off the cuff here live, but it makes it a little more interesting. So, the error you saw pass by there is because I just realized I'm running Java 11 right now. So if you're curious, does this work on Java 11? It sure does, but apparently there's some weird reflection going on there that is confusing things. Now we hit refresh and we should see, okay, let's wait for it to finish. There are test failures. Well, right now I don't think I care. Well, while that's spinning up, let's figure out where the presentation went. So at any rate, we get an error, disable the security, and try again. And it's not super exciting. What we're going to see is an OK message. So that's a lot of work to show you something really underwhelming. So we want to make it do something a little more interesting. So let's change that endpoint. So if we come here to our controller, and this has a lot more stuff in it, but basically we want to change that so that we are returning a string. And we'll see if the server has started. Author not found. Well, that's kind of interesting. Localhost 8080. Oh, okay. Sorry, I modified the default to the default project to add a little more interesting stuff. I changed the endpoint on that. Well, I didn't like that either. We'll do it from the command line like we're meant to do, right? Okay. It's the server is returning a content type of JSON. The browser is then trying to render that, but it's actually a string, which you can't see back there very clearly. But you can see the response there is author, as we expected, but Firefox just can't figure out how to encode that as, or how to represent that as JSON, so we get a funny little error. There we go, author. So that's what we expected to get. So that works. Whew. And if I can find too many windows open. All right, so that's not super exciting, but it is something a little more interesting. Before we get too much further on it, though, let's take a brief detour and look at dependency injection. Everybody's familiar with the dependency injection. Okay, it's 2019. Hopefully I don't have to explain that, but every now and then. So the DI in Micronaut, which it's a homegrown DI tool, so it's not Juice, it's not Spring, it's not CDI. And that's done largely to minimize dependencies and minimize reflection, as I noted earlier. Does support constructor, field, job being property, and method parameter injection. They tend to favor constructor injection, which I think is probably just a good principle. If your object needs that class to run, then you should inject it in the constructor, is the idea behind that. But every now and then you might need other reasons for injecting other places, and the DI tool supports that. Should not be any surprise, but whatever you're injecting needs to be managed by Micronaut. I mean, obviously, if it doesn't know how to build it, doesn't know how to create the instance to inject. So you make something Micronaut managed, if you will, by using, you can use some of these annotations, Singleton, there's only one in the system, context, prototype, infrastructure, thread local, refreshable. I won't go into detail on all of those. Probably moderately familiar, at least some of them. But at compile time, it's going to find those annotations on things and do all the wiring necessary to start that. I don't know if it's lazy or not. You know, if you annotate something Singleton, is it going to create it at startup time or only when it's needed? I don't know that offhand. Seems like that would be a good startup optimization. Just create when you need it. But you can also use a factory method. There are times when you need something from an external library that you don't have control over. You can't change the source. So you can create a factory method, which is like the produces in CDI, if you're familiar with that. And I'm sure Spring has an option. I just haven't used Spring in a long time, so can't really say. Like I said, annotation processors for Java and Kotlin, produce at runtime. If you're really, really curious, you can look at the output directory and see the Java classes that are generated. It writes those, obviously those .class files to disk, so it can package that in your archive, and you can look through that if you want to. It's really weird. There's a lot of subclasses and dollar signs and stuff, but if you like that sort of thing, it's there for you to geek out on. AST transformations provide the Groovy support. That was really important to them. They didn't want to exclude such a huge part of their customer base. They're migrating Grails 4 to use this, and as Grails continues, they'll migrate more and more to use Micronaut where they can without breaking things. Obviously, Grails right now is heavily based on Spring, so a lot of those annotations, they can't just change it and break everybody, but they're moving what they can. Scala support is planned. If you're unfortunate enough to be using Scala and want to use Micronaut, it's coming. Scala doesn't support the annotation processor right now. It does have a compiler API, and they're working through that to provide Scala support. Their goal is to make this usable for, you know, as much of the JVM market as they can. I think, you know, certain language. I don't know if you ever see Clojure support. That'd be kind of cool, but I'm sure both Clojure users would be ecstatic. Since reflection is not used in Constructor of the bean, the JVM can inline and optimize the code far better, resulting in better runtime performance and reduced memory consumption. I stole that from their the marketing slides on their website. But that's like I said, that's one of their goals for them, is to make that as small and fast as possible. And dependency injection is super simple. You probably didn't notice that in the controller because I didn't necessarily call it out. But I've got a controller. It's marked at Singleton, and it's without. I don't have to put add inject in there like I do in CDI. I just have a field on the constructor, and it's going to go find that and inject the author service for me. So to see, I mean, there's really not much to look at there. And this is Kotlin code for those of you that are not familiar. Basically, this is the primary constructor syntax, in case that's kind of confusing. It's going to be a private variable on the class. It is a val, so it is immutable. I can't change that at runtime. The variable name is author service, and in Kotlin, the type comes second. For those of you not familiar, the language designers felt that was a little more natural. As you scan the line, what is this called? Oh, it's an author service. What's the type? Oh, it's author service. Not very surprising here, but usually we want to know what it is before we're too concerned about what it is or what it's called before, or what it is. So that's why you see that syntax there. And then I'm free to use that. If I want to, I could put this in a field and put, I think they do have an add inject annotation on there and have to make it lazy init so the compiler is happy and that kind of thing. But that's dependency injection. It's pretty simple. I'm sure there are some more complicated use cases, but in my little pet project work, I haven't had to stray too far from the beaten path. So, all right, persistence. Anyone here using JPA? Yeah, there's one person suffering with me. I like JPA. It's a Typesafe deal. Anybody using ORMs in general? Hibernate. So if you use Hibernate, it should be pretty familiar. I like JPA. I'm a big standards guy. I spent years working on a Java EE project or two, so big fan. Micronaut makes working with it really, really simple. You saw in the config, I just said hibernate JPA, so it's going to add the dependencies for me. Oh, there's a big clock on the wall. All right, dependency added when create the application. This is what the config looks like. Nothing real exciting there. Notice it says default. You can have multiple JPA configs, and while I've not figured out exactly how to do that, I think that allows you to inject different JPA configurations in different environments. In this case, I want to scan a particular package. I want to automatically create the DDLs. I want to bring up the application. It's going to create the database for me. Probably not something you want to do in production necessarily, but for testing and demonstration, it's great. And show SQL in case you're just curious what's going on the scenes. We also need to define a data source. Obviously, we need to know how to talk to the database. We're going to talk to the highly performant H2 database, but it's nice because it's in memory. You don't have to worry too much about it. You can define multiple databases as well as needed. All right, so we're going to do this in a service, and I've, big fan of layers where appropriate, so I've just made very thin layers. We've got the controller, takes the request. We've got the service that's just going to do our persistence. You might do business logic here, maybe have another layer that actually does the data persistence. It's your app. You can build it how you want. Notice we've got Singleton. We just want a single instance of this. I believe if I put the context, if I use the context annotation on there, I'll get one per request. Or I think it's tied to the scope of what it's injecting into, perhaps. But in this case, I just want a Singleton. I do need to put the @around annotation on there that signifies to the annotation processor that we need some around advice in certain places. If I don't do that at runtime, when it calls, say, find by ID, it's going to say something about method needing around advice, but not finding something. It's not very helpful. But if you see that, you've probably missed the @around annotation. It would be nice if it would just understand that transactional needs that and apply it manually. But one of the things they said, well, I guess it's generated code, but they said they were very clear that Micronaut does not change your code. Your bytecode is your bytecode. Some projects that would do this, like Project Lombok, will take your code and then just beat the snot out of that thing, doing weird things. And you get to production, and it's failing on line 137 of a 12-line class or something. So very hard to debug. You get line numbers in a stack trace with Micronaut, you're going to know exactly where it failed. So anyway, here's our author service. You notice we are doing some injection. I specify the persistence context annotation. And I know the question going through your mind, why an annotation here and not in our service? And the answer is, I don't know. I lifted that from the example, actually. I was kind of trying to come up to speed. But that is the JP annotation. We want to inject the entity manager here. It is val, and it's incidentally is public. You notice I didn't specify a scope on there, not necessarily related to Micronaut, but more in the language, the Kotlin language in particular. Everything's public by default because we usually specify scope, whatever that's called, context. Drawn blank on the word. We usually specify all that on properties and methods and stuff. And I figured we'll save ourselves some time because if we want something that's not private or protected, we have to put public. We can save ourselves 7 characters, public plus a space. So at any rate, side note on there. The first one is transactional. It's read-only. We're searching for anything, so we don't want the server to start a transaction because that can kind of be expensive. But it does have to run in the context of a transaction because that's just the way JPA and the entity manager works. And then we're going to return entity.find. Notice there also that is the Kotlin syntax. If you call class name .class, you get a K-class object in the Kotlin environment. But obviously, if you're passing that to a non-Kotlin library, it's going to want the class definition. So you call K-class.class or .java, and it returns the actual class object that the JVM natively understands. And the other one, just to show another example, we want to add an author, mark it as transactional, unless we don't mark it read-only because it's actually going to do some work. We call persist, and then we return the author. And based on how JPA works, that's going to persist that. It's going to set the ID. So when we return that, our author now has an ID associated with it. All right, Singleton annotation, kind of covered that, covered that. All right, before we get to security there, I don't know that there's a whole lot more in the service that is super interesting, but if you'd like to see it in context, in very small text, I'm not going to take the time to change the font size on that. All this is on GitHub, so if you can't read it clearly, you can check it out and play with it. But you can see I've got a number of methods there. It's just your typical CRUD operations, some lookup operations. Not real exciting. If you're familiar with JPA, maybe you're brand new and you find that extremely fascinating. But all right, so we're going to batten down the hatches. We want to secure our web service, obviously. We don't want to just run it out there in the wild, most likely. As noticed, it comes with JWT support. It's pretty basic, but it works, which is pretty cool. And depending on your environment, maybe that's fine. Enabling security requires a config change. We saw that option. I'll turn that back on here in just a minute. And annotating methods or a class as desired with the annotation. I don't know where that isAuthenticated method is, but that's an expression language. It's going to call isAuthenticated on something. But the @secured will secure either a method or every method in the class if you put it on the class. It can be as simple as implementing just a couple of different interfaces. They've got a really simple and a not quite simple approach. I went with a really simple approach because it's a little easier to consume. In this case, it's an authentication provider. I'm going to actually, we'll look at the code here in a minute. We're going to authenticate our users against a database and return the token. And the password encoder it's a nice injectable interface to allow us to encode if we want to use a certain algorithm, or if we want to use a salt somewhere and look that up, if you want to jump in the middle of that. So we'll look at the code here in the IDE because it's a little bit nicer. The authentication provider, that is hard to read. My apologies. It's an interface with one method, with the authenticate method. And again, I don't want to spend too much time on the Kotlin language, but I heard at least one or two say they weren't familiar with it. So we define a class. It is public. Classes are final by default, so don't let that surprise you. We're injecting two objects in the constructor. That :authentication provider says we're extending that interface or implementing an interface. And we're going to override a method or a function from the parent class or interface called authenticate, and it's going to take an authentication request. Now, one of the awkward things about working with Kotlin, interoperating with Java, generally speaking, the advice I got was, what library should I use in Kotlin to do foo? And the answer was, well, whatever you use in Java, right? And I found that to be absolutely true. I've not found any library that I can't use in Kotlin. However, there are some things that Kotlin kind of does for you, null checks and stuff, that the Kotlin compiler cannot determine when it's coming from Java. So sometimes using those Java APIs might look a little weird at the source code level, and that's kind of what we see here with this, with the generic. It's authentication request. In our case, we don't really care what the types are, so we're going to take just about anything. So that's what that's for. We're going to return a publisher of type authentication response, and here we declare a new variable called val. A new variable called user as a val, so it's immutable. Compiler will fail if you try to define that. And we're going to call userService.findUser, which again is just it's another JPA service that is going to query the database. Like I said, super simple deal here. We're going to select the user where the email matches and return a single result. And if we get more than one, then we're going to just print the error and return a null. Probably not the best approach, but again, just trying to keep it simple for the demo. All right, so we're going to look up our user. If we have a user, if the user is not null, and the password matches. So in our database, we're storing the hash of the password. So we're going to hash, again, the password that the user passed in, and we're going to use that via the injected password encoder. That's not very exciting. It's like a SHA-256 hash or something. Although, so yeah, see there, matches. It's just a check there. The encode is where we do the work. So not exciting there at all. But what we're going to look it up. If the password matches, then we're going to return a user details object that gives us the user, and then the system for us automatically will create our JSON Web Token for us. We have configured in the file, and I'll pull it up in just a minute, the key used to sign the token, and then as those tokens come in, it'll verify the signature on the token for us, all automatically. We don't have to do any checks once we issue the token, which is kind of nice. If we don't find a user or the passwords don't match, then we're going to return a flowable that has an authentication failed object in it. Kotlin does not use the new keyword, so you see the class name and parens. It's creating a new instance. And that's authentication. That's all we really have to do on that. So if we re-enable security, notice here, this is where the config kind of comes in. For issuing the token, it's enabled true. We want to do that. Signature, kind of a nested config there. The secret that we're going to sign with can be overridden from the command line with that environment variable, or we can use that. And obviously, they remind us that we need to change that before we go to production. There's the encoder. All right. Let's look at the test. All right, so I have slides on this. I'm kind of jumping out of order, but I'm running short on time. I want to make sure we kind of cover most of this. Like I said, testing in Micronaut is super simple. What I have here is a fairly typical JUnit 5 class, and all I have to do is put the @Micronaut_test annotation on there. And what that does for us is when we run this test, I believe it's like a JUnit run or something, it's actually going to start the server for us. We can do all that manual if we want to. There's some APIs for creating the application context on the server. I don't care about that. But what this is going to do for us, though, is going to start a server. So all that production code we see is going to run. And then it will also allow us to do injection. And we can see here on line 25 here, 25 and following, we're going to inject something. Not sure what that field is on there, but we're injecting a client, and we are specifying the base URL of that client. So everything that we do will be based off that. It is here on that, what we see there, that slash. If you have clients configured, if you're doing some discovery, you want some external service, and you want to look the URLs up from a config file, or if you're using console, for example, to find those services, you would enter the ID here, and then it will automatically look in the config or whatever. Oh, that's console. Let me go out there. I need this URL. It'll get that and return it for you. So you've externalized that. In this case, we're just testing our local server, so we're just going to inject an RX streaming HTTP client. So it does ship with this very low-level client, if you like, but it also has a Typesafe client that we'll take a look at in just a moment. So we're going to inject that. Notice late init there. We have to do that, or that has to be marked nullable for Kotlin purposes. I don't like dealing with nullable if I can avoid it, so we do late init, and it's going to assume that it's actually initialized before your code runs. We're also going to inject our author service. I'm going to cheat a little bit and set up some test data. But in this case, we're going to test, well, I've got a before service. That's where the author service is used, and I'm going to create some test data. It's kind of a hacky way to do that. But for testing authentication, we're going to create a post request, and we're going to log in, and we're going to pass it a bad user. We're going to create a blocking request. We're going to pass the request object we just passed, and we're going to expect back a bearer access refresh token. So the login endpoint, which it defines, I believe, is going to return this access token for us, and that's what we're going to return. That's what we're going to get the token from. The login method here is really the interesting because this does a good login for us. We're going to post to the login. We're going to pass our username credentials, our username password credentials object. Basically, it's a basic auth kind of request. We're going to send the request, expect an access token back. And here, since this isn't a test, I go ahead and assert that the response is okay. And we're going to turn the response body, which is going to be a JSON object with the token. Now, I do use that method elsewhere if you're curious. Nowhere that's accessible. Here this is a kind of a Kotlinism. It has a string interpolation, so you can embed Kotlin code in your string. That's what's going on there. If it's just a variable, you can say $variable name. But if you want to pass something a little more complex, like a method call, which is what we're doing here, it's $curly brace. And I call the login method, and I'm going to pull the access token back out of that. So login returns the bearer access refresh token object, which has the bearer token embedded. There's the Java source for that. You can kind of see the properties. Don't want to dive too deep. That's not necessarily real interesting. But I do want to pass the authorization header. You can see this is how we're authenticating against our service. Probably better ways to do that. But this makes it clear what's going on. And that's how you pass in your JWT. If you're not familiar with that, is everyone familiar with JWT? I know I just kind of blew past that. It's a JSON Web Token. It's somewhat of a standard that allows you to, rather than pass using password back and forth, you log in, you're given an access token and a refresh token, and then you just pass that token in. And then the server, rather than taking username and password and hitting your data store and verifying that, can then take a look at that token and using the key, the secret that we saw defined, can then verify the signature on there. So, all right, this token matches the signature. I can trust this token. And inside that token, you have what they call claims, which is really just a nice confusing, it's basically a key value. I claim that this user ID is this, or I claim that my roles are. And then you can pull that information from the token without having to hit your user store. So it really lightens that side of things. You can tuck anything you want to inside that token, but you have to keep in mind that that token is a JSON object. It's got 3 parts. I don't go into the details on that. And eventually that token is then given a base 64 hash, which is what we see on the access token. So we get a base 64 string, then the server decodes that, rebuilds the JSON object, verifies the signature, and you can pull the claims out of there. So it's really kind of cool. You log in once, put in information you want in there, and you have stateless authentication on your server because the client holds the state. We just verify that it hasn't been changed. If someone does change it, obviously invalidates the signature. You reject the token and redirect the user. So that very quickly is basically what a JSON Web Token does. Really, really cool. There's a talk by David Blevins, if you want some more information on that, deconstructing the state of security or whatever, and he kind of walks through that whole process. It's got kind of pictures to show you the implications of that in terms of traffic and load on your servers. Go to tribestream.io, I think. You can find that talk. Really, really helpful. So that's what's going on. We would want to pass that in the header, and then the server, in our case, is just going to verify, yep, this is a good token. I know who this is, and we'll return things. We're not doing anything real fancy on the server side. Remember in our controller, like if I want a list of authors, and I call this method, all I'm worried about here is this user authenticated? And he sure is. But if I want to, I can put, I think it's @roles allowed on some of these methods. Anybody can look at authors, but only these people can create. I can specify roles on there. And I showed you the easy authentication. The not as easy actually has an interface you can implement, then pull roles from somewhere else. So you authenticate the user, then you build a list of roles, and then it uses all that to build the JOT. And you can put those roles in your token. I didn't do that here because I just didn't feel it was worth the complexity. There's probably already a lot of moving parts in this as it is. We're going to test. We're going to log in every time. This is probably also isn't the best way to do this. You might for the test, or certainly for production, you're going to log in, save that token in your mobile app, in your web app, a cookie or whatever. Logging in every time is kind of expensive. It kind of defeats the purpose of the token, because then you're still passing username and password. Over SSL though, right? We're not doing anything over plain HTTP anymore. So that's the test. Now, Micronaut does have a Typesafe REST client that you can build. You can implement an interface. And if you want to, you can define an interface that defines the contract for your controller, get authors, update authors, whatever, and have a class implement that interface, and then have your demo client, or your Typesafe client, also implement the interface and do nothing else. And then with that at client annotation at compile time, the processor is going to see, hey, I've got an at client interface here. I'm going to generate code that makes all these calls for me. So all that code you saw me doing earlier with client to blocking and all this, it's going to generate that for me. So what I then have is an object. It will inject an instance of demo client for me, and then I can just call client.login, client.getIndex, client whatever, and I deal with actual types. I'm not worried about JSON objects and strings and things. And I've got a kind of a stripped down example of that. Some more fun setup there. So create author. Here I've got that in 3 steps. I could do that probably actually in 1 line of code if I really wanted to. Well, I'm doing some equals there. But I'm creating an author. Notice also Kotlin allows named parameters on classes. So if you've got 18 parameters, you only want to specify 1, just give it a name, and the compiler figures that out for you. I'm going to call client.createAuthor. I do need to pass the authorization header and the object. This is why I didn't implement the interface, because on the server side I don't need that parameter, but on the client I certainly do. So I'm passing an auth_z, which is the just the bearer token, and notice I have this annotation on there, at header authorization. It's going to take the string, and that's going to put that in the header, and then for get author, that's going to be a path parameter there. If I want it in a body, for example here, when I create an author, I'm going to take an author object and I'm going to post that to the service. I can use the @body annotation, and it's going to know when it generates that client, I want to take this object and pass it as the post payload. So then I just call create author. I pass it the string, which I actually, in the setup, I did log in once. I did this one right. Before each test I log in, so it's not quite the same, but JUnit's kind of weird. You know, before class has to be a static method, and then things have to be static, and it makes everything else look weird. I didn't care to go through all that. So, but that's what's going on there. I'm passing the token. It sticks it in the header for me, and it's going to put author in the body, and then when I get that back, I'm going to get an object of type author, which I can then do some testing on. So really cool. You can also, this doesn't have to be used in test. If you've got a service of some sort that has to talk to some external service, you can actually write an interface. I want to call these Twitter API methods. You create an interface for just those methods. It generates the client for you, and you do it all in Typesafe way. Inject the URLs if you want to load balance. There's only one Twitter API, I guess, but you know, if you've got internal services, you've got an order service or whatever, you can have 4 of those stood up, or just one, whatever. You stick it in console, let it inject. So this lets you externalize all that. Really, really cool. Any questions on that? I'm short on time, so I'm trying to micro machines my way through this. Well, isn't that nice? There was a reason I quit using PowerPoint, and all right, so more sophisticated solution, back to security, should integrate some sort of authentication service. As a general rule, unless you really know what you're doing, you don't want to implement your own security, because it's really easy to get wrong. And when you get it wrong, really bad things can happen. So it does come with support for the AWS API gateway if you're in the Amazon space already. A couple of other options are, I've mentioned Tommy Tribe has a Tribe Stream API gateway. It's a very lightweight, easy tool. It's kind of nice too because it handles all the user creations done there and management. You can actually revoke tokens. It's part of the JWT spec. The token can live for so long, and then you might have a refresh token that lives a little bit longer, so a service connects, and that token's bad, and you can send the refresh token and maybe get another one, but if that refresh token is also expired, then you can redirect the user to a login. And this handles that for you. It also has hooks so that if you want to modify the token before it returns, you can specify an endpoint that it calls back into your application. Say, what do you want me to stick in this token? You return some data. It sticks in the token, signs it, and returns it to the user. It's pretty nice. I don't know cost or support or whatever. Red Hat's Keycloak, if you're familiar with that, that's the Red Hat identity management product. Really nice. At some point, I'm trying to put together something on that. It's a really cool system. So, but anyway, you want something sophisticated, but I'm not very sophisticated, so this is what we have. I'm not ketchup on a steak, unsophisticated, but all right. So, like I said, the pretty basic. There is a JWT claims set generator if you want to do all this in process. Yeah. I mean, if you want to do all that yourself, and for small internal services, maybe that's fine. That lets you customize what you put in there. If you want more details on that, there's a link to that. I'll have a link to the guides at the very end. The guides for Micronaut are awesome. They've done a great job of documenting a lot of stuff. It's a little weird sometimes, you know, if you're writing Kotlin and Maven, and the examples are all in Groovy and Gradle, so you have to do some translation. But we're all professionals, so it's not too bad. It's just a little weird when you look at it. I went through testing, it's built in. It does support JUnit, 5, Spec, and Spock. The default template does create a spec-based test. I don't like spec, probably because I don't know spec. I'm familiar with JUnit, so that's what I tend to go to. But if you like either of those, then you're in luck. I don't know about TestNG is currently not supported, but it could be. It's all open source. So embedded server dependency injection works. Easy testing, I've kind of jumped ahead. All right, odds and ends, I'll run through this real quick. Major advanced, I think I've mentioned all this. Service discovery, it supports Consul, Zookeeper, and Eureka out of the box. Distributed tracing, Zipkin, and Jaeger. I guess maybe someone's a beer fan, I don't know. But if you want to trace a call through a series of microservices, it's got support in that, so it'll trace it and you can log that to something, figure out where time is spent or things are going sideways. Message-driven microservices, super simple to set up a Kafka listener. It's an annotation, you run it, and I mean, it's really easy. CLI support, if you want to build a command line tool. I was going to show that, but I've talked myself out of time, but using the Pico CLI library, you can easily create Java command line libraries. Management monitoring, it's got that built in. There are a couple options. Gradle VM support, I mentioned that. Small example, I can't go through it right now, but if you specify Gradle native image support, it will set up a bash shell script to build the native image. It creates a Docker file for you, so you can build your Docker image to deploy or what have you. Just some alternatives. Sometimes it helps to think of something new in terms of something you already know. Microprofile, which is kind of how I discovered Micronaut. I've been working with, like I said, Java EE, not Jakarta EE, for a really long time. Microprofile is a subset of those Java EE specifications that are tailored to building microservices. It's a lot of the same libraries, but if you're in a Microprofile 2.0 compliant environment, you know these sets of libraries are available. And there are at least 7 or 8 different implementations of that. Helidon is one of them. I called that out specifically because it also has a Java SE mode. Honestly, I'm not sure what the difference is, but there's Helidon MP and Helidon SE. So it's a little bit different. Quarkus is something that's fairly new. I don't understand a whole lot yet. It was actually announced last Friday at like 7 a.m. Eastern time. It's from Red Hat. It's a Gradle VM specific thing, and it's as best I can tell from what I've looked at so far, there seems to be a lot of overlap with Quarkus in terms of, or with Micronaut in terms of functionality. They do still, though, use a lot of the microprofile stuff. It does do reflection. but they feel with the Gradle VM they can make that fast enough. They don't need all the extra work of avoiding reflection. So there's some differences there, but still very, very cool. If you want to go look, Quarkus.io, I think is the website. Spring Boot, that one's been around forever. Drop Wizard, maybe even longer. Spark Java. Eclipse Vertex. I mentioned earlier, that's a very unopinionated framework, and it's really different. You write vertices, and it's kind of bizarre. For me, I'd say bizarre. That's not fair. It is unfamiliar. That's a kinder way to put that, right? Nothing wrong with it. People write great applications with it. And there's a Scala project called Logom that's even stranger to me. But there are a lot of options. There's like 13. I saw one guy tweet a list of 13 different JVM frameworks, and that's just ones that are Java, and there was one Kotlin, one Ktor. You throw in Scala, you get 5 or 6 more, so you've got a lot of options. All right, so resources. You can find the Micronaut home at micronaut.io. The guides are there. I think one of the quotes I grabbed was from this Java Magazine article. It's a really good introduction to Micronaut. Covers probably most of what I covered today, but probably more eloquently. So if you'd like to go read that, kind of fill in the holes or whatever. My info there, you can see my blog site, my Twitter, and my LinkedIn if you're curious. And I've got nice little redirects, so I get to use my blog URL over and over again. So we're really short on time, but are there any questions that I can try to answer? Yes, and I meant to point that out. So here in source main resource, I have application.yml. I meant to show these endpoints. You can actually, if you enable these endpoints here, beans will show you every bean configured. Info will give some information about the server. If you turn on monitoring, you can go to the metrics endpoint and get information. But I have this very large config here, and you notice. Well, I commented out because I was having problems with some Gradle stuff. But in theory, if I have this in my config file, sorry, this microphone's my way, so I'm kind of dodging it. But maybe your default production config looks like that. You want to connect to Postgres on the local host, but in your test, obviously you probably don't want to do that because it makes it harder in CI environments. You have to make sure Postgres runs. Kind of annoying. So in my test, I went to actually talk to H2. So here in application-test, remember earlier on that slide, I kind of glossed over it, but it's application-environment. And other than production and test, I'm not sure what other environments there are. But I can override that and point to an H2 database, so it starts up and creates the H2, and I'm doing in memory there. I'm trying to think, I saw a lot of, it turns out that I'd been planning on doing this talk for a couple months, then I get the Dev Nexus schedule and the makers of Micronaut there, so I went to a lot of sessions on it to try to fill in some holes. And I'm pretty sure, I can't remember if it was a Micronaut or microprofile, but if you have external config in some service and you make that change, I think it was reflected immediately, but I'm not 100% sure. Yeah. But if it's in a text file like this, I think even on the text file, it modifies or monitors that local file and will pick up that change. Yep. I would test that, but we're short on time. I'll have to play after. So any other questions? All right, so I have to show that because I spent the time to make the slide. So, but that's all I've got. I can try to answer questions offline if you have any more. If not, you can check out this demo there from the Git repo and Bitbucket, and look, I've got a blog post or two on Micronaut. So anyway, that's all I got. Thanks so much.